y is equals to sine, y is equals to sine of 3 over 2, 3 theta all over 2. So now let's find the following. I'm just going to make this as an example. So this is just our example number 1. So I want you to know how basically we're going to solve the following questions that I'm about to write. So example number 1. On number 1, they will actually say find the period. Period. On number 2, we're going to find the amplitude for the graph y is equals to 3 theta over 2. And then on number 3, we're going to find the domain and the range. The domain and the range. And then on number 4, we're going to find what? The x and y intercept. Intercepts. And then on number 5, we're going to find the maximum and minimum turning points. Maximum and minimum turning points. Sorry for my handwriting. So this is the equation that they're giving us. Y is equals to sine of what? Sine of 3 theta over 2 all over 2. So these are our solutions. So since the first question they want us to actually find what the period, this is what they're going to do. We're gonna say period, it's equals to, then you use the formula of determining the period. That's gonna be 360 all over k from what I've just showed you, right? And then this basically means to say our period is gonna be what? 360 over what? Who can tell me? Over what? That will be 360 over k. So this basically means to say in this case, let me use a different color. In this case, our k represents 3 over 2. Don't get confused. So it's the same as using 3 over 2. But you know that math doesn't allow us to have many division signs. So to be on the safe side, this is how you can actually write it. You'll just say period. It's gonna be equals to, that is 360 degrees, and then we're having a divide sign. We'll say divide by k, which represents 3 over 2. Then you can just write this as 360 or punch everything on the calculator. And then you say times. Remember, when you have the division sign, you introduce a multiplication sign, then you swap them 2 over 3. Then let's find our period. Tell me what's the answer. Is it 240?
204.
Yeah?
Yeah. 240.
Yeah, it should be 240. So it means to say the period of the graph y is equals to sine 3 over 2 theta, we're getting 240. So if we got 240, then you're correct. Then you go to number 2. The second question, they want us to find the amplitude. Who can tell me what is going to be our amplitude? Remember, they gave us the equation y is equals to sine 3 over 2.
Erase it.
So what is going to be our amplitude? our amplitude is going to be 1 because here we're having 1. Then that one here it best explain to say we're speaking about an amplitude. The pity part is that they didn't draw amplitude. They didn't draw the graph. If they would have drawn it, I will actually show you how basically you get that. By just saying maximum minus minimum divided by 2, then you get the amplitude. Then on number 3, they want us to find the domain and the range. Domain it will be what? What will be our domain? So for us to find the domain and the range, let us sketch the graph first. And I forgot to write the restriction. We are actually given a restriction where they tell us to say our restriction is what? Is theta is less than or equals to 180 degrees. I'm just gonna interpret it now, don't worry. And then greater or equals to what? 2 minus 180. So this basically means to say we are dealing with the what? We're dealing with the trigonometric function cosine. And remember, I told you the other day to say for you to master how to draw the graph of y is equals to this one, y is equals to sine 3 over 2 theta, you must be in a position of knowing how to draw the mother graph, which is represented by y is equals to the sine of what? The sine of theta, just like that. And then for you to be able to know how to draw the domain and the range, let us now draw this graph. And then take in consideration that we're going to use that as our restriction. So as we are going to draw that graph, they're telling us that theta is less than or equals to 180 or greater or equals to negative 180. So this is what you're going to do. We're going to draw a Cartesian plane. And then that Cartesian plane will range between minus 180 as well as 180. Right? So the amplitude is always 1, or it changes. The amplitude is not always 1, it can change. In this case, if I can give you the graph, y is equals to 2 sine 3 theta all over 2. It means to say this 2 is going to be the amplitude in this case. Now let's continue. Sure, so now let's continue. So we are going to draw the graph. So they're saying from negative 180 up until 180, right? So you can use the step, what? You can use the step of 45 if you want. Because if you're gonna use the one for 360, it will be too small. So 45, 90, 45, 90, 135. Then it's followed by what? By 180. Then this one. 1, 2, 3, 4. So that's 45 degrees. That's 90. That's 135. And then that's also 180. So this will be negative 45, negative 90, negative 135, negative 180. Because now we are adhering to our restriction. Remember, they told us to say we must draw the graph where theta is less than or equals to 180, or theta is greater or equals to negative 180. So I've managed to actually show you to say when they're saying theta is less than or equals to 180, this is 180, less than, you're going that direction. Or theta from here, theta is greater or equals to negative 180. This is 180, greater than, you're going that direction. So we're gonna use that. Then how do you draw your graph? You understand that since it's a sine graph, from the mother graph, sine 0 is 0, sine 90 is 1. So here we'll just say 1. Then there we'll say -1. And then now you draw your graph. Remember, this again is going to be the y-axis. This again is going to be the x-axis. And then there are many ways in which you can draw the graph. Let us use that one of the table of what? Table of values method. So with regards to saying that is the table of values method, remember, here you're going to have theta as well as another one, which is sine of 3 theta over 2. Then since you've used the step of 45, this basically means to say we'll start at minus 180, followed by minus 135, followed by minus 90, minus 45, 0, 45, and then 90, 135, as well as 180. Remember, why I was ending at 180 is because of based on the restrictions that will have given us at that. Then you on the other side, make sure that you use a ruler so that your work is much neater. And then from there, let's punch that on the calculator and get get the corresponding values. So when you punch that on the calculator, the one for -180, we're gonna get 1. Are we all getting 1? Then this one, it's around 0.38. And then the one for -90, it's gonna be what? Minus 0.71. Then the one of -45 is minus 0.92. And then the one for 0 is gonna be 0. The one for 45, I think it's 0.92. And then the other one for 90, it's 0.71. Write 0.71 here. Then the one for 135, it's gonna be minus 0.38. Minus 0.38. And then lastly, this one of 180, we're gonna get -1. Then you go there, you plot all those values that you actually got. So how are we gonna plot those values? So remember, -180, it goes with 1. This one is 1. And then -135, it goes with 0.38. 0.38. And -90 minus 0.71. Minus 0.71. And then the one for -45, it's minus 0.92. And then the one for 0 and 0, 0 and 0. It's gonna be there. 45 and 0.92. 90, it goes hand in hand with 0.71. 90, 0.71. Then 135 minus 0.38. 180 negative 1. So you on the other side, this we're drawing it. If you have the proper graduation for your ruler, I think we'll go on the correct side. You can actually see that there's light at the end of the tunnel. Then when it's now like this, now much easier to go and draw the domain and the range, because there's no way you can interpret the domain and the range if you don't know how to draw the graph. So since you have just said that is our graph that we actually draw now, let's now continue with the concept of us writing what is the domain, what is the range. So domain, when we speak about the domain, it's all possible values of x. So it will be x is an element of, so now mind you must be very careful with regards to drawing or writing the domain, because if you're gonna write the domain without taking consideration the restriction that you had from the original onset, which is this one, then everything will now become wrong. What am I trying to say? Let me show you. Since domain is all possible values of x, I'm gonna say x is an element of brace, since I know that it starts here at negative 8.
Then you put another bracket.
Yes, negative 180, 100% correct, comma, then it ends at 180. I'm gonna write it like this. Am I right writing it like that? Yes, I'm 100% correct. Then now we're writing the range. So in maths, the range we are speaking about all possible values of y. So it basically means to say the range of this one starts where? At -1, and it ends there at 1. Let me show you. Start at -1, yeah, then it ends in alignment at 1. So that is going to be the range. Domain all possible values of x, range all possible values of y. Are you all learning? Or I'm speaking to myself?
Yes, sir.
Okay. So that is the domain and the range. And then now we go to the other question, whereby they want AMA x and y intercept. That's number 4. They want AMA x and the y intercept. So when I speak about x and y intercept, it's very easy. X and y intercept. So x intercept, you always say let y is equals to 0. So you're gonna go to your graph, you check AMA x intercept work. You're gonna check your x intercept. So what are gonna be your x intercepts? One of it is 0 and 0, because remember, this graph it passes there. So when you speak about x-intercept, that's where the graph passes, right?
Yes.
Yes. You can write 0 and 0. That will be your x-intercept. And then your y-intercept It will be 0 and 0 because y-intercept, you say let x is equals to 0. And then with regards to that, not only 0 and 0, it will be also minus 120 and 0. It will be also 120 and 0. So those are gonna be your x-intercept, and then y-intercept is only 0 and 0. We're done with that one. And then the last question on number E.
No, sir.
Yes,
128 tlhaele kae?
120 tlhaela kae? It's a good question. And get our x-intercept or let y is equals to 0.
Yes.
Yes. It's one and the same thing. Or let y is equals to 0, you take the equation, in the place of y, you put 0, and then you solve the equation. You'll get 120. Or it's a matter of how you draw your graph, you'll actually see. That's why I'm saying that one it's negative 120, because if this is
Or what?
negative 90, here, that's negative 120. If you wanna see if maybe I'm correct or wrong, let's say, Konje, you're gonna say this one minus, just say 90 plus 135 divided by 2. I wanna see if you're gonna get 120. Let's say 90 plus 135 over 2.
It give us 112,5.
112, comma.
5.
Okay, but our x-intercept is gonna be 120. So for you to get this one accurately, so use the concept that I've just showed you to say, just because of you want the x-intercepts, put y is equals to 0 on the equation
Okay.
and solve it. You're gonna get straight 120, just like that. And then on number 5, the last one, they want what? They want the maximum and minimum turning point. And minimum. So another concept, that's why there's a reason why I draw this graph, so that you can be able to see our maximum turning point, so that you can be able to see our minimum turning point. So
Point.
yes, turning point, that's where the graph turns. So the maximum turning point, let me write them down for you. So our maximum turning point, it will be minus 180 degrees together with what? Together with 1. And it will be what? 60 and 1. And then our minimum turning point, our minimum That's going to be minus 90 together with what? -1. So one thing that is very important, guys, when you're dealing with this, you must always check the graph given. If they didn't give you the graph, it's a must that you must draw. Then they're gonna also ask you those questions, not forgetting to say under the amplitude. I showed you to say there is a formula
Maximum.
with the amplitude, which is maximum minus
Minimum. All
1,
over 2.
2. So you must know this formula, then I think you'll be on the safe side. So yeah, for now, I think these are some of the things that you must know. But if you check the trend, I started by doing like this. I took the original graph, y is equals to sine theta. And then secondly, spoke about this one, y is equals to a sine theta plus q. Today I've introduced this one, y is equals to sine k into theta. And then the last one that you might actually come across, let me remember, is this one, y is equals to sine of theta plus p. But if you check whatever I'm teaching you, myself when I teach, I don't leave things behind. I'm just teaching you the concept of you knowing the original graph, of you knowing this one, that is the vertical shifting, this one that is k, as well as this one, because in an exam you'll actually come across either one of those. And then if you don't know how to get even the period, then it's going to be a problem. Any more question? Any more question?
No questions.
Okay. It means to say we are done on the trigonometric graphs for sine, cos, and tan. We are done. We have exhausted everything that has to do with you knowing the sine graph. You know why I'm saying that? It's because of, if you can check all this formula, all of those that I wrote here. This one is y is equals to sine theta, the mother graph, followed by this one that is a vertical shifting, y is equals to a sine theta plus q, followed by this one being the third one, y is equals to sine k theta, followed by the fourth one, of which the next session will be basically introducing the fourth one. Then we dive into me showing you how to understand the ones for cos, and then we also do the ones for tan. You know, the way I'm teaching like this, if you are wise enough, you'll take previous question papers. There's no way you will even struggle, because I'm just showing you different types of functions under the category of sine function. The way I teach maths, I don't like rushing, because if I can rush and say, let us do the question paper now, the whole information that I'm giving you now, most of you will struggle. But there's a reason why I teach like this. I'm just enlightening you to say, if you are seeing something like this in an exam, don't panic. This is how basically we solve it. That's why I might not teach you a sine graph, cos graph, and tan graph in a day. There's a reason why I don't teach like that. Because most of you will be confused. But the way I'm teaching it like this, I know that you have wrote notes for yourself, then you're good to go. There's no way you can struggle with regards to this, unless if maybe you don't understand at all. But the way I'm teaching, I think all of you are on the safe side of you making sure that you're gonna pass at the end of the day, because I'm just one person who explain a lot of information and basics doing few examples. I'm just like that. Most people who teach maths, they give you a lot of examples, where else information, it might be limited, just because, and then at the end of the day, if that's the case, you might find that you are going to struggle to solve that particular question. Any question?
No questions.
Do you all understand? Kifilo, do you understand?
Yeah.
𝗬𝗍𝗁, do you understand?
Yes.
Tembile, do you understand? The Nancy, do you understand? 𝗏𝗏, do you understand? 𝗂𝗿𝗄𝗄, do you understand? 𝗏𝗏𝗃, do
Yes,
you
sir.
okay, 𝗏𝗏𝗃, do you understand? 𝗬𝗏𝗃, do you also understand?
Yes, sir.
Okay, so yeah, these are some of the things that you must know. And then on the next session, I will be introducing this one. Y it's equals to a sine of theta plus p.
Plus P.
Yes. Okay, let me just guide you. Some of you, but you know this. If maybe they give you this one, y is equals to the sine of maybe x plus 45 degrees. When they're saying x plus 45 degrees, in reality, is that this graph is shifted 45 units to the left. So it's a concept by if it's plus 45, we shift it 45 units to the left. It's minus 45, we shift it 45 units to the right. So the next session, I will be basically doing what? Introducing those. And then after I introduce only this part, give you information about this, then I'm going to go to the course one, explain a lot of things, show you different types of formulas that you'll get when working with the course graph, make examples, give you homework, and then we go to the tan graph. After that, I know that we'll have covered the more information that regards to those graphs. And then I'm done teaching under trigonometry. I taught you trigonometric identities. We did prove trigonometric identities. I showed you how do you work with the Cartesian plane, theorem of Pythagoras. I showed you. Now I'm showing you trigonometric graphs. I'm going to show you the sine graph, which is this one. We are done. I'm going to show you cos graph. I'm going to show you tan graph. And then after that, the only last part that will be left with under trigonometry, it will be trigonometry that has to do with 2-dimension and 3D. After I'm done teaching 2-dimension and 3D, basically means to say I will have taught you the whole syllabus of trigonometry. Remember, I also taught you general solution under trigonometry. So it's a lot. If you're wise enough, you can actually see that this it falls under, this it falls under. I will keep on telling you so that you don't forget. This is paper 2. That is trigonometry. Paper 2 is out of 150 marks. Trigonometry on its own is 60 marks. So it's very easy to pass maths because on paper 2, you'll find trigonometry being 60 marks. On paper 2, you'll find Euclidean geometry, the one of Tanko theorem, the one of angle sine semicircle, the one of angle at the center is 2 times angle at the circumference. You see that Euclidean geometry? Yes. 2 tangents drawn from the same point outside the circle, they are equal in length. You'll actually see when we are dealing with it. When I'm speaking about trigonometry, it's 60. That Euclidean geometry that I was emphasizing now, it's 50 marks. So if you kill trigonometry, you get 60. If you kill Euclidean geometry, you get 50. That's 110. For you to get a distinction on both papers, distinction is 80%. 80% of 150, if you calculate it, it gives you 120. So if you kill 60%, you get total trigonometry. Euclidean geometry, get total, that's 110. And then you'll be left with only 2 chapters. This is Trig 60, 50 marks geometry, and then you'll be followed by analytical geometry, which is 25 marks. And then you'll be followed by what? You'll be followed by statistics, which is going to be 15 marks. There's no way you can fail statistics. So on statistics, it's very easy. They will give you box and whisk. They will say calculate the mean, mode, range, calculate interquartile range, calculate the what? Maybe the number of learners who are in the 20th percentile. So that is stats. Stats is very easy, straightforward. Under analytical geometry, things that you must know perpendicular lines, that product of the gradient when you multiply them is -1. Parallel lines in analytical geometry, they have equal gradient. You must also know distance formula. You must also know the formula of determining the gradient. You must also know formula of an inclination of a line. Tan theta is equal to the gradient of AB. You must also know collinear points. Collinear points, those are points which lie on the same straight line. What happens? They have the same gradient. It's very easy again, analytical geometry. Then you are done. It's very easy to get a distinction in maths. It's very, very, very easy. The only thing that one needs to do is to make sure that you do what you practice every now and then. And then there's a lot of you guys who are struggling. Sorry about that. With Euclidean geometry. We have not yet started Euclidean geometry. But the key that I can give you with Euclidean geometry, for you to get a distinction or master Euclidean geometry, don't start by practicing those ambiguous riders, where else you don't know all the theorems. Remember, we are having 8 theorems under Euclidean geometry. Theorem 1, the line drawn from the center to the midpoint of a chord is perpendicular to the chord. Theorem 1 converse, the line drawn from the center of the circle perpendicular to the chord, it bisects the chord. We are done. That's theorem 1. You go to theorem 2, angle at the center is 2 times angle at the circumference. You go to theorem 3, if the diameter of the circle subtend an angle at the circumference, then the angle subtended is a right angle. That is angle in a semicircle. You go to theorem 4 of a bow tie. Angles in the same segment are equal, or angles subtended by the same arc chord are equal. You go to theorem 6. Opposite interior angles of a cyclic chord are supplementary. When you speak about supplementary angles in maths, these are angles that add up to 180 degrees. You go to theorem 6. The exterior angle of a cyclic chord is equal to the opposite interior angle. You go to theorem 7. The angle between a tangent and a chord is equal to the angle in the alternate segment. You go to theorem 8. Two tangents drawn from the same point outside the circle, they are equal in length. If you know how, as I'm mentioning them, I'm not looking at them. They're in my heart. You know why? There was a time whereby I practiced them a lot. So if you know how how we name them, if you know how to familiarize the diagrams, if you know how to prove them, if you know how to apply them, then even if I can give you a writer, you'll be able to get a distinction as easy as that. Any question?
No questions, sir.
Yeah, you'll see. I'm not a genius. Practice makes perfect, guys. Ne? The key is in practicing. Practice makes perfect. So we are done for today. Thanks, guys, and apologies for whatever happened due to network.
No
But
problem.
okay, sharp, guys. Bye-bye.
Bye.
Mm.